Here are the lesson 16 homework solutions. I'm going to pause the video, check those. I am going to go over numbers 5, 6, and 8. And if you need help with any others, just let me know. Bubbles and fish. Fish and bubbles. All right, here's number 5. We're going to take this sine theta. We're going to switch it to an x. So I'm going to let x be sine theta. So we have 8x plus 1 equals negative 3. Subtract the 1 to give me 8x equals negative 4. Divide both sides by 8. Negative 4/8 reduces to negative 1/2. So sine theta is negative 1/2. So I need to find where sine is equal to 1/2. But first of all, I need to make sure I know what quadrants I'm in. Sine is negative. ASTC. Sine's negative in T and C. So I'm looking in those two quadrants. First, I got to figure out where sine is equal to 1/2. 30, 60, 90. Sine opposite over hypotenuse is equal to 1/2 when we're dealing with 30 degrees. So 30 degrees is my magic angle here. Got to go to the T and C quadrant, put in a 30-degree reference angle in both of those, figure out those angles. This one is going to be 180 plus 30, which is 210. This one is going to be 360 minus 30, which is 330. There are your two answers to number 5, 210 and 330. Here's number 6. Take the tan theta, switch it to an x. Let x equal tan theta. So 3x minus 2 equals x. Got to solve for x, so we probably should move this 3x over to the other side, giving us negative 2 equals negative 2x. Divide both sides by negative 2, and I get x equals 1. Looking for places where tan is equal to 1. This is not going to be the unit circle. If you were thinking unit circle, no, because remember, tangent is sine over cosine. You're not going to get a 1 from any of that on the unit circle. Where you find tangent equal to 1 is your 45, 45, 90 triangle. Tangent, opposite over adjacent, or opposite over adjacent, depending on which 45 you use, doesn't matter. Either way, 45 is our angle. Now we're looking for places where tangent is positive, because this is a positive 1 right here. So tangent's positive in the T quadrant and the A quadrant. So we're here and here. And 45 is our angle. So we're going to draw a 45-degree reference angle in quadrant 1 and in quadrant 3. This angle right here, of course, is just 45. This one, though, is 180 plus 45, which is 225. There is where those two angles come from in that solution. Here is number 8. Number 8 is a little tricky just because it's in radians. All right, so we want to first solve for x. So let's just replace this cosine with an x. So we have 3x minus radical 3 equals x. Need to get x by itself, so let's subtract 3x from both sides to give us negative radical 3 equals negative 2x. Divide both sides by negative 2 to find out that x, negative divided by negative, is radical 3 over 2. So remember, x was cosine. So I'm going to replace that back with cosine again. Looking for an angle where cosine is radical 3 over 2. We're going to find that from our 30, 60, 90. 1, 2, radical 3. Where is cosine adjacent over hypotenuse equal to radical 3 over 2? That's going to be at 30 degrees, because the cosine of 30 adjacent over hypotenuse is radical 3 over 2. So 30 is our magic angle. Remember that we're dealing with positive radical 3 over 2. So we're looking for places where cosine is positive. Cosine is positive in A and C. Had to fix my light. So I need to take 30 degrees and draw it in the A and C quadrant. Well, in the A quadrant, it's just 30. But in the C quadrant, it's actually 330. Because it's 360, but it's 30 degrees less. So 30 and 330 would be the answers if you were putting them in degrees, but we want them in radians. So I got to switch those to radian measure by taking 30, multiplying it by pi over 180 and reducing. 30 goes into itself once, it goes into 186 times. So this is pi over 6. There's one of the answers. 330, hey, out of room here. Right here. 330. I can put a 30 into both of those. 30 goes into 330 11 times. It goes into 186 times, which gives me 11 pi over 6 when I reduce it. So 11 pi over 6 and pi over 6 were your answers in radians. All right. Let me know if you have more questions on the homework. If you need me to go over any of those other ones, I can. Want to do those three because I thought those were the most challenging ones on the homework. If you need more, let me know.